Hi again everyone, Chris Tisdell here again. In this presentation I'm going to continue my series of videos on complex numbers. Now in previous presentations I introduced the idea of the complex conjugate of a complex number, and I motivated it and did some examples and talked about the geometry. And in this presentation I'm going to do another example involving an application of the complex conjugate. So let me share my screen with you and we can get underway. All right, so we're asked to prove the following. For all complex numbers, z, we have the square of z is the square of the conjugate of z, if and only if the real part of z is 0 or the imaginary part of z is 0. Okay, so now before we actually prove it, let's dissect this a little bit. Okay, firstly, if say z is x plus yi, then the conjugate is x minus yi. Okay, and geometrically speaking, if you plot z in the complex plane to get z bar, you just reflect the point in the horizontal or real axis. Now this if and only if, this sort of phrase is sometimes abbreviated to IFF, if. Right, so what it means is, if that's true, then that's true. And if that's true, then that's true. That's what if and only if really means. Okay, now, some of the ideas that we're going to use in this presentation have been discussed in previous presentations, right? In particular, the properties of the conjugate. Okay, and in particular, these two properties are going to be used. If you take a complex number and you add its conjugate and divide by 2, you get the real part of that complex number. And if you take the difference, then you get the imaginary part of that complex number. So we're going to rely on those things today. Now, sometimes this, the curly R here means the real part of Z. Sometimes some books write it as RE of Z, and this curly I is the imaginary part of Z. Some books write it IM of Z. Okay, so how do we do this problem? Well, I'm going to start with the difference of these two things. Okay. So I'm going to have z squared minus the square of its conjugate. And this is just the difference of two squares, right? So I can write this as z plus its conjugate times with z minus its conjugate. Now we can see, okay, well, I can use, if I rearrange this, bring the 2 up here, I've got z plus z bar is 2 times the real part of z. Z minus z bar is 2 times the imaginary part of z. So I can replace each of these brackets with the following. Okay, when I'm actually handwriting, I do like to use RE and IM. If I'm typing something up, though, I just use these symbols. Now, this is 0. Right? This product is 0 if and only if one of these things, or perhaps both of them, are 0. Okay, so for this to be 0, the real part of z is 0, or the imaginary parts of 0 is 0. Okay, so I've actually just shown what we were asked to show. Okay, we've shown that this is 0 if and only if this is 0 or this is 0. So that's the proof. Okay, so we used the basic properties of the conjugate down here, and we started off with the difference of these two things. Okay, so that's another example designed to illustrate how to apply some of the properties of the conjugate. Now, let me just share my screen again with you. One part in the very first part in this list, z times its conjugate, or z times z bar, is the sum of the squares of the real and imaginary part of z. Now this turns out to be the square of the distance from z to the origin. And to prove this, you'll just expand this out. A squared minus b squared times I squared. Okay, so that'll be, because I squared equals -1, that'll be a squared plus b squared. And the other parts, we'll cancel out. You've got a times negative bi and bi times a. So when you add those together, they become 0. So this is actually the square of the distance from z to the origin. Now, in forthcoming videos, I'll discuss the idea of distance from a point in the complex plane to the origin. And the distance is referred to sometimes as the modulus of a complex number. So that's the next step in this series of videos. I'll be talking about distances and the moduli and their properties. So I hope you can join me for those presentations. If you have any comments, any feedback, any suggestions, you can put them in the comment section below. I'm always keen to get feedback. So thanks for watching. Hope you can join me for the next presentation. Bye.